Our next section is 10.3 on scientific notation. Start with, let's define what is scientific notation. So n is a number. Then if I want to write it in scientific notation, I need to write it as a times 10 to the n, where a is in between 1 and 10, and n is an integer. So a cannot be 10. A can be 1. A has to be in between those two. So let's look at an example, because that just sounds strange. Let's say I have 4,800. That's n. So I need to write that as something that's between 1 and 10 times 10 to a power. Essentially, I need to write this as something times 10 to the something. And I need it to be equal to 4,800. Certainly, 4,800 is equal to 480 times 10, right? So times 10 to the 1. I can write that. It's true. But this 480 is not between 1 and 10. So that's not really going to help me. I need to work harder. I can write 4,800 as 48 times 100, which is 48 times 10 squared. Still not good enough, though. 48's too big. But if I multiply by one more, I can write it as 4.8 times 10 cubed. You want to think of that 10 cubed as moving the decimal place over, right? And that 480 is if I move the decimal place over once. The 48 is if I move it over twice. 4.8 is if I move it over 3 times. So if I write 4,800 in scientific notation, I have 4.8 times 10 cubed. Let's also try one that's the other way. Let's say I have 0.00048. Again, I want to think of myself as moving the decimal point over until I have something that's between 1 and 10. So I'll move my decimal point over once. 0.0048. No, that's definitely not between 1 and 10. I'll move it over again. 0.048. No, still not good enough. So I've moved it twice. Move it 3 times. 0.48. Nope, that's not between 1 and 10. One more time. 4.8. 4.8. Oops. 4.8 times 10 to the... I've moved my decimal point 1, 2, 3, 4 times, and I've moved it in a negative direction. 4.8 times 10 to the negative 4. If the number that you started with is less than 1, your exponent should be negative. If the number you started with is bigger than 10, your exponent should be positive. Yeah? Why are we doing this, though? That seemed like just a silly notation, and it seemed pretty unrelated to what we've been doing so far. But it allows us to use the rules that we've had so far, all of our rules of exponents, to do things we otherwise wouldn't have been able to do. Let's consider this example. That 4,800 that I just had over 12,000. Let's say you don't have a calculator. You need to be able to do this computation. That's not something you can immediately do. But if we convert both of those numbers into scientific notation and then apply the rules of exponents that we already have, it's something we totally can do. We already did 4,800, right? We said that was 4.8 times 10 to the third. I move my decimal place 1, 2, 3, 4 times to get something between 0 and 1, between 1 and 10. That gives me 1.2 times 10 to the 4. And my number was definitely bigger than 10, so that should be a positive 4. So I have 1.2 times 10 to the 4. 4.8 divided by 1.2. That's something I can do, right? 4.8 divided by 1.2, that's just 4. So I'm going to divide this fraction into 2 halves. This one and this one. 4.8 divided by 1.2, that's 4. And I'm multiplying that by 10 cubed over 10 to the 4th. I can apply my quotient rule. This is 10 to the 3 minus 4. 10 to the negative 1. So in scientific notation, I have 4 times 10 to the negative 1. If I wanted to change that out of scientific notation, right, I just want my number. I know that 10 to the negative 1 is equal to 1 over 10. So I have 4 out of 10, or 2/5. But if you want your answer in scientific notation, there it is. Okay? We can use scientific notation to simplify questions. Combined with our rules of exponents, it can allow us to easily answer questions that otherwise would have been pretty complicated.